Awesome. Okay, so just a quick introduction. My name is Becca Bussard. I'm a PhD candidate at the University of Oregon. My research is primarily using geodetic methods, primarily InSAR, which you will hear a lot about in this talk, to study volcanic systems, primarily in the Cascades. This is my second year doing the USIP internship. I worked here last year and had an excellent time, so I wanted to come back and kind of tackle some of the stuff I didn't get to do last summer. So today I'll be talking to you about that. And I'll be talking about the development of InSAR resources for education and data accessibility. So just a brief outline, I'll go over what InSAR is. This is a pretty geodetic community, so I'm sure most of you probably know, but just to get everyone on the same page, I'll then talk about some of the web content for the UNAVCO and later on EarthScope website that I helped a bit with Lucia on. And then I'll be talking about the InSAR product archive, which was a lot of fun this summer to work on for me. And then wrapping up with the InSAR processing and theory short course that I'll be helping out with, and then I will summarize. So starting out, InSAR, also known as interferometric synthetic aperture radar, is just a geodetic method capable of measuring ground deformation, and its main benefit is the high spatial resolution. So we've heard a lot about GPS in these talks, which is another fantastic geodetic method, which has excellent temporal resolution, but obviously with GPS, you have it at specific points. InSAR, on the flip side, you can image a wide swath of area. However, the satellite will only fly over the same area given every 6 days, 12 days, or in some cases 35 days for older satellites. So that is kind of the trade-off with InSAR. I will say over the last few decades, the number of SAR satellites has dramatically increased, both in terms of kind of government agencies as well as the private sector over the last couple of years has really expanded their SAR capabilities. And this has allowed a lot of different applications of InSAR, which I will be talking about later in the talk. But so one of the things I got to do on kind of, I already got a great introduction from it from Lucia and Zach's talk, but I got to do the What is InSAR page, which was a lot of fun. InSAR has kind of been one of the main methods I've used throughout my research, both in undergrad at Penn State and at Oregon. So being able to just kind of write this summary page of InSAR was a lot of fun. I got to talk about how the technique works at kind of a middle level, with some geodetic understanding, but also making it clear for people that might not have used it before, since InSAR can be a bit terminology heavy. Even the acronym for what it stands for is a mouthful to say. I described the different satellites that use InSAR. You can have airborne InSAR as well as spaceborne, and the applications, which was something that I was very interested about. I'm not sure how many know, but NASA, in conjunction with the Indian Space Agency, will be launching a new InSAR satellite coming, I believe, sometime within the next couple of years. And one of their big missions has been really trying to incorporate all of the new applications of InSAR. And that was something that I really wanted to do. I come from a very solid Earth background as I study volcanoes with InSAR, but I wanted to expand on that, both for my knowledge and also so that the resources that are available can be for a wide range. So essentially, that was another part of what I got to do this summer. I wrote 4 pages of the different kind of application realms for InSAR. I got to do my bread and butter, InSAR and solid Earth, but then I got to learn a lot about InSAR and cryosphere, hydrology, and ecosystems, which was honestly a ton of fun. I obviously have never kind of used InSAR data in those ways before, and there's actually a lot of creative uses of it that I was learning about for the first time, both in terms of kind of altering the original data or just a different way to kind of use InSAR time series, which was really exciting to learn about and just kind of see over time how people had kind of tweaked the technique to measure or just kind of view their specific target area. Another fun aspect of this was just being able to practice my science communication. As it was kind of said before, we do a lot of technical writing, so being able to just kind of write out these general summaries for kind of the general public was a lot of fun, and just kind of to be able to express how much this technique can actually do. On the flip side of kind of general science communication, I also got to do a bit of coding this summer, which I also do enjoy. It was a nice balance of both with the InSAR product archive. And essentially what the InSAR product archive was created to do was to house InSAR products for comparison between InSAR experts, and then hopefully kind of for use by non-experts to pair with their data, with the goal in mind of greater data accessibility and reproducibility. So this is kind of the website that you come on WinSAR's page. And essentially it has kind of the InSAR product map, which lists all of the products as well as your own specific products. It also goes into specifics about the data format specification, and then that GitHub link that's in the middle there kind of houses my scripts that I wrote this summer. So yeah, the archive itself uses a very specific file format, uses HTF5 files, which I had some experience with just because different InSAR softwares use those files, but I got to really dig deep into how those are structured this summer, essentially because my goal was to update existing scripts and also make others to take products that were made with current software versions and make them uploadable to the archive. So that was kind of a lot of fun to look at that from a much more technical aspect of what metadata should be included, how it should be structured, how to structure it, just because InSAR data, it can be very large, can consume a lot of space. So being able to essentially put that in an H5 file that's uploadable and also downloadable on the website was something new for me that I had a lot of fun reading about. So this is that GitLab page that I was talking about earlier that was on the website. Essentially what I did this summer was update existing scripts for GMT-SAR and ICE, which are two InSAR processing software suites. You see GMT-SAR there, and then ICE has both StripMap app and TopSap for different satellites data. So I got to update those to just match kind of current, some things had like change with terminology and things like that. So to match current terminology. So those are now working, and you can upload interferogram pairs, which is just when you take 2 days of SAR data, combine them to get ground information just between those 2 dates. And then even more exciting was that I was able to figure out how to get both displacement time series products and velocity products from MinPy, which is one software suite that people within the InSAR community use to produce those. And I was able to get those into uploadable products to the archive, which is very exciting. InSAR pairs can be useful, but whenever you have a time series or a velocity map, that's a bit more usable by kind of other researchers, possibly outside of InSAR, because it can have time series of ground deformation over whichever area that you're studying that other people can look at and kind of compare. It was also really nice too, because since I was writing the script, I could also think about which metadata I wanted to include for all of these. So this is essentially kind of what it looks like from the end user perspective. This is just kind of all of the products that I uploaded over the summer. Most of them were just kind of messing around to see what would work, what wouldn't work when uploading them. But when you click on one, you essentially get all of the metadata listed. Some of it I decided to include, others were already kind of preset, so I made sure that all of the products I was reading in had those. You also have a download URL, so you can just download the file. You can request the DOI. So this was a lot of fun to just see come to fruition, just from the starting point of not a lot working with it to now multiple software suites being usable, as well as actual time series and velocity maps. And then the last thing that I'm kind of doing this summer, which kind of goes back to more SciComm, although I will have to be kind of talking about a bit of the theory, is I will be helping TA for the InSAR processing short course, which kind of teaches either beginning users or kind of intermediate users about the InSAR scientific computing environment, also known as ICE. I helped with them last year and they appreciated my help, so I agreed to help them again this year, which essentially just kind of involves answering questions from students, attending office hours, giving whatever knowledge I have about ICE from my own experience using it. So, which was very rewarding last year. It was really awesome to help people use the software that I've used for a while, just because it can be a lot your first time, and having people kind of show you how to use it can be a lot easier than just trying to tackle it yourself. So just in quick summary, this summer I was really able to do a lot about InSAR, which was a lot of fun for me. I got to develop educational resources for the wider geodetic community. And then I was also able to update and improve the InSAR product archive, which my goal is to help promote data accessibility and reproducibility with having these products and their metadata available. That way you can have these products and you can know kind of how they were created. And then I will also just be helping again with teaching about InSAR processing and theory later on this summer. I just want to acknowledge UNAVCO, the UNAVCO Student Internship Program, for funding my work and taking me again this summer. I've had a blast both summers. And I'd also like to thank my mentor, Chris Crosby, for all of his mentorship and taking me back and letting me kind of really just have a fun InSAR-filled summer. So if anyone has any questions, I am happy to answer. Thank you for listening.
Thanks, that was great. Questions for Becca? You can type them, you can raise your hand. You have options. Okay, I have a question then. What was one of the main things that made you want to come back? Because you also stayed longer last year as well. So obviously you like us, but what was one of the reasons?
I honestly, so part of it is just that UNAMCO has like a ton of geodesy people, which kind of I do both geodesy and volcanology. And where I study now, Oregon has mostly volcanology people. So to be able to kind of go to a more geodesy centric environment was really fun. I also do have to shout out Chris again. He's a really good mentor and is always just very helpful for whenever I need. So I was able to get a lot actually done and just have kind of reproducibles, which is fun when you're doing your PhD and you're kind of used to much longer term projects, to actually be able to get stuff kind of concisely done and say, yes, here's a product from over a summer, was really enjoyable last year. So I wanted to do it again.